Question 7.63. To determine the muzzle velocity of a bullet fired from a rifle, you shoot the 2-gram bullet into a 2 kilogram wooden block. The block is suspended by wires from the ceiling and is initially at rest. After the bullet is embedded in the block swings up to a maximum height of 0.5 centimeter above its initial position. The first part of the question is asking you to find the velocity of the bullet on leaving the gun's barrel. So here in this question, you have a bullet being fired from a rifle and it hits the block. Mass of the bullet we will write as mb, which is equal to 2 gram. We will divide by 1000 to convert this to kilogram, so 0.002 kilogram. Whereas mass of the wooden block, which we will write as mw, is 2 kilogram. And once the bullet hits the block swings to a maximum height h, and value of h is 0.500 centimeter, which is equal to 0.005 meter. We need to find the velocity of the bullet Vb with which it was fired from the gun's barrel. So in order to find this velocity, we can use the law of conservation of momentum. Now, when the bullet is fired from the gun, it hits the block and is locked inside of it. So this is an example of inelastic collision. And in order to find the bullet's initial velocity, we can use the law of conservation of momentum. But to use that law, we need to know at least the final speed with which both the block and the bullet move, which we will call as v. And in order to find this speed, we will use the law of conservation of energy. So let's look at this part of the question where the bullet hits the block and the block swings to a maximum height with the bullet embedded inside of it. We will call the lowest position of the block as 1 and the point at maximum height as 2. We know from the law of conservation of energy at any 2 point in motion is equal. So we can write for total energy at point 1 to be equal to total energy at point 2. Total mechanical energy can be written as the sum of kinetic plus potential energy. So we write kinetic energy at 1 plus potential energy at 1 to be equal to kinetic at 2 plus potential at 2. At the lowest point, since it is your reference point, the height h is 0. So we can take the potential energy at 1 to be 0. Whereas at the highest point, velocity v becomes 0. So kinetic energy at this point will be 0. So we write K2 as 0. Then we are left with kinetic energy at the bottom to be equal to potential energy at the top. We know that kinetic energy K is written as half mv squared. This m over here is the combined mass of the block and the bullet as they stick to each other. The bullet is embedded inside the block. So I will write the kinetic energy over here as half. For the mass m, we will combine the mass of the block and the bullet. So mass of the bullet plus mass of the wooden block into their common speed squared. This will be equal to potential energy at the top, which is the gravitational potential energy. And gravitational potential energy U is mgh. Again, m here we will write the combined masses. So we write mass of the bullet plus mass of the wooden block times g into h. So let's cancel off the common term, which is the combined masses of the block and the bullet. And we get v squared by 2 to be equal to g times h. Or we can rewrite this as v squared equals 2gh and v equals square root 2gh. Let us call this as equation 1. This is the speed of the block and the bullet together once they collide with each other, the combined speed. After I found the combined speed of the bullet and the block after collision, I can use the law of conservation of momentum to find the speed with which the bullet left the gun's barrel. So now we are going to look at this part of the problem. So here we are going to apply the law of conservation of momentum, which says that for an isolated system, total momentum is always conserved, which means that total momentum before collision must be equal to total momentum after collision. Momentum before collision is the sum of the momentum of the bullet and the wooden block. Momentum of bullet we can write as mass of the bullet into velocity of the bullet. The wooden block initially was at rest, so its momentum will be 0. After collision, they stick to each other and move with a common speed v, so we write their momentum as mass of bullet plus mass of the wooden block into the common speed v. I want to find the speed of the bullet, so we write Vb divide by mass of bullet on both sides. So Mb plus Mw over Mb. The common speed V we found in equation 1 to be square root 2gh. Now we can substitute to find this velocity. We write Vb to be equal to mass of the bullet is 0.002 kilogram. Mass of the wooden block is 2 kilogram. Square root 2 times g, which is 9.81, and the height, which is 0.005, divided by the mass of the bullet, 0.002. And when you solve this, you get the speed of the bullet to be equal to 313.5 meter per second. So this is the speed with which the bullet left the gun's barrel when it was fired from the rifle. Now let's discuss part B. What is the velocity of the block after collision? So after collision, the block and the bullet move together with a common speed v. And we already found an expression for this common speed in equation 1. So we will write v equals square root 2gh. Now let's substitute. This will be equal to square root 2 times 9.81 into h, which is 0.005. When you solve this, you get the speed with which the block is moving to be equal to 0.31 meter per second. Let's discuss part C of the question. What is the tension in the wire when the block is at its lowest position? Take the length of the wire as 1 meter. So when the bullet hits the block, they stick to each other and move with a common speed v. So their combination starts with the speed v and reach a maximum height h as shown in the figure. And we need to find what is the tension in the wire at the lowest position. Now tension is a force. If you want to find the magnitude of a force, you need to first identify what are the forces acting on the block at that position. So the first force we have here is the force due to gravity, which acts vertically down. So I'm going to write this as Fg. And then we have the tension in the string pointing towards the suspension point, T. And since the block moves like in a circular path, there is an acceleration present, which is the centripetal acceleration. So we write the equation of net force as F net to be equal to m into AC, where AC is the centripetal acceleration and m is the combined mass of the block and the bullet. F net is the net force acting on the block along the y-axis. So we write F net as T minus Fg, which is equal to m into AC. So T minus Fg we can write as m into G, which is equal to m into AC. Now m here is the combined mass of the block and the bullet, which I will add them later while substituting. So we can write T as mg plus mac. Take the m out as common, mg plus ac. AC we know is centripetal acceleration, and centripetal acceleration can be written as v squared over r, whereas m over here is the combined mass of the block and the bullet. So it will be mass of the bullet plus mass of the wooden block. So we rewrite T to be equal to, for M, let's substitute MB plus MW. Then we have G plus, for AC, we will write V squared over R. V here is the combined speed of the block and the bullet, which we found in part B of the question, and that value of V is 0.31. R is the radius of the circular path. In our situation, it is the length of the wire, so R will be 1 meter. So let's substitute. Mass of the bullet is 2 gram, which is 0.002 kilogram. Mass of the block is 2 kilogram. G is 9.81 plus V is 0.31 squared over 1. So we get tension in the wire at the lowest point to be equal to 19.8 Newton.